Hello everyone, welcome back to my channel. In the previous video, I had discussed about the gates. What we have seen that for each gate we have written a Boolean expression, the one which is giving us the relationship between output and input. That how can we express the output in terms of input variables? Like for example, for AND gate we can write output y is equals to A and B, or for OR gate y is written as A or B. These are known as Boolean expressions, and in this video I am going to discuss about the Boolean expressions only. Now Boolean expressions, they provide a shorthand method to describe a logic circuit configuration by mathematical equation. Like this is the mathematical equation for AND gate. This one is mathematical equation for OR gate. Or we might have the longer expressions like y is given as a b c plus a b complement c, or a complement b complement c, like this also. So these Boolean expressions actually indicate that how many logic gates are used, what type of logic gates are required, and how they are connected. Like for this particular case, we can say that we need two NOT gates, one for A complement, second one for B complement. And then if we have the availability of three input AND gate, then we need one AND gate for this particular term, one AND gate for this, and one AND gate for this. And then we need one OR gate also. So this is how we can actually decide that how many gates are required just using the Boolean expression. Now, it is very important to understand that how to draw the logic diagram with the minimum number of gates. Because if we use large number of gates, that will actually increase the delay. Now, what we mean by delay? When we are giving input to one of the gate, that is coming out as, then we have the output of that gate. So there is some propagation delay. So as we keep on increasing the number of gates, the propagation delay that also keeps on increasing. So it is very important to minimize the Boolean expressions. There are two ways to minimize the Boolean expression. One is use of Boolean algebra. Second one is use of K-maps. One way is use Boolean algebra. This Boolean algebra will have some laws and rules. Second one is use of K-maps. K-maps I will discuss in the next video. In this video, I'm going to focus on this Boolean algebra, which will have some laws and rules. So let's discuss them one by one, and then I will take some examples also showing the minimization of the Boolean expressions. The first law is commutative law. First law is commutative law. This is applicable for the addition of variables, also for the product of variables. What it says that A or B is equals to B or A. Now this means the order in which the variables are odd, they make no difference. If we are first giving A as input then B, then that will give the same result if we are giving first B as input then A. Similarly, it is applicable for the multiplication also. That means A dot B is same as B dot A, means how the variables are added together, that sequence doesn't matter. Second law is associative law. So associative law is there if we have three variables. So it says if A or B, then B or C, they are same as A or B or C. Means the result of ORing operation of several variables is same irrespective of the grouping of variables. Like on the left hand side, firstly we have OR operation of B and C, then they are OR together with the A. While on the right hand side, firstly A and B they are OR together, then the result of that is ORed with C, but both will give us the same value. Similarly, it is applicable to the product also, which says A dot B dot C is same as A and B, then with AND operation with C. Again, it means that AND operation of several variables is same irrespective of the variable grouping. Third law is distributive law. This distributive law is actually used for expanding the equations. Now it says A is having AND operation with B or C. This is same as A and B or A and C. This means ORing of several variables and then ANDing will result in a single variable, which will be same as ANDing single variable with each variable then ORing them together. Means here A is a single variable that is ANDed with B or C, and here this single variable is ANDed with each variable that is with B and C, and then they are ORed together and their result is same. Then there are certain rules also. Now, what are the rules for Boolean algebra? This is the first rule is A and 0 is always 0. Now, here A can be 0 or it can be 1, because 1 and 0 is always 0, 0 and 0 is always 0. Then A and 1 is always A. Now, if A is 0, then 0 and 1 is 0. If it is 1, then 1 and 1 is 1. So any variable when it is having AND operation with 1, it will result in the same variable. Similarly, A or 0 is always A, but if we are having A or 1, then it results in 1 only, because this is a OR operation. OR operation says either if either of the inputs is 1, then output is always 1. So since this one is fixed at 1, so it will always result in 1. Now this is not the addition, it is the OR operation. Then AND operation of same variable with itself will result in the same variable. Like 0 and 0 is 0, 1 and 1 is 1. Then AND operation of a variable with its complement will always result in 0. What's the reason? Because if this variable is 1, then its complement is 0. Or if this one is variable is 0, again it will result in 0 only. Then if we have the OR operation of a variable with its complement, then it will always result in 1. Because variable can have either value as 0 or 1. Either the variable is 1 or its complement is 1. And in OR operation, if one of the variable is 1, then result is always 1. Then we have the OR operation of a variable with itself, that will result in the variable itself only. Like if 0 or 0, 0, 1 or 1 is always 1. Then next law is double complement of a variable will result in the same variable. Means if this is variable is 1, then its complement is 0, then complement of 0 is again 1. And same is true for if we have variable as 0. Zero's complement 1, then 1's complement 0. So it will result in the same variable. So then we have Absorption law. Now, what is absorption law? Absorption law says A or A and B is same as A. Now, how it comes from here? If we take A as common, then this is 1 plus B. Now, 1 plus B, from here, what we have seen, any variable and its operation with 1 always results in 1. So, this one is 1. So, A no 1 is same as A. So, basically, this is the use of these Boolean rules in order to achieve the absorption law. Similarly, another law is there, A plus B to A plus C is same as A plus BC. Now, how it comes, we can just check it. If we expand this Boolean equation from the left hand side, firstly we have A into A, then A into C, then AB, then we have B into C. So A into A is A only. Then we can combine it with AB, just rearrangement of the terms. Then from here, if we take A as common, then it becomes 1 plus B plus C plus BC. Now, any variable added with the 1 or having OR operation with 1, that will always result in 1. Whether it's one variable or we are having OR operation of 1 with two variables or three variables. So this will result in 1. So this term changes to A plus BC. So these are certain laws which will actually help us in minimizing the Boolean expressions. Now, in addition to these laws and rules, we have two theorems as well, which are known as De Morgan's theorems or De Morgan's laws. So these are used to simplify the circuits containing NAND gate or NOR gate. Like if we have to design any circuit using only NAND gates or only NOR gates, in specifically over there we need to use the De Morgan's theorem. As per De Morgan's first theorem, AB complement can be expressed as A complement plus B complement. And as per second theorem, A plus B complement is same as A complement and B complement. So this one is particularly about the NAND operation. This one is about the NOR operation. Now let's take some examples for the simplification of Boolean expressions. Now first example here is simplify the expression y is equals to A complement plus B into A plus B. Now what we need to do, we need to use as many laws as possible which are there available with us. Either it can be some theorem or law or some rule. Now what can we do? We can firstly expand this Boolean equation. When we expand, so first term is A complement into A, then we have A complement B, then AB, then B to B. So this one is as per the rule, any variable when it is having a AND operation with its complement, that always results in 0. Then we have A complement B, and AB. Any variable having AND operation with itself results in the same variable. From here, what we have, B is a common variable. Then we have A complement plus A plus 1. Now, when 1 is having OR operation with any variable, it always results in 1. So that this expression is simplified to y is equals to b. Now, what we see over here, if we don't minimize this Boolean expression, then we need one NOT gate here. Then we need OR gate, then AND gate. So basically, as per this Boolean expression, without any minimization, we need 4 gates. But when we have minimized, this one is simplified to just one variable. We don't need any gates to minimize this, to realize this. So this is how the minimization helps. Now, second is again to minimize a Boolean expression, which is given as y is equals to ABCD plus ABCD complement plus A complement BCD plus A complement BCD complement. Problem is minimize expression y. Now, how can we minimize? We have to take some common terms and then apply the rules. So, firstly, what we need to do, from the first two terms, A, B, C, they are same. So, y can be written as A, B, C, then D plus D complement. Then from here, we have A complement, B, C, they are same. So, we can just write them A complement B, C, and what we are left with D plus D complement. So, D plus D complement is always 1, because if D is 1, then this is 0. If this is 0, then this is 1. Same over here. So y changes to A, B, C plus A complement B, C. From here, B and C, they are the common terms. Then we are left with A plus A complement. Again, A plus A complement is 1. So y reduces to B into C. Now, if we just compare two expressions, here we just need one AND gate, but over here we need so many gates. So I hope this is making it clear that why we need to use Boolean algebra, some laws of Boolean algebra or rules. Then we can also have some problems like prove that A complement B complement C plus A complement B C complement plus A B complement C complement plus A B C complement is equals to C complement. Now this is what is given to us. We have to prove it. For that, we are going to consider left hand side only. So this one is equals to from first term, if we see what is common. Okay, first term is not A, B, A. This is A complement, B complement, C complement. Now from this equation, from the first two terms, A complement, C complement is common. We are left with B complement or B. Then from these two terms, A and C complement again common. So we are left with B complement plus B. So this is again 1. This is 1. This is equal to A complement C complement plus A C complement. From here, C complement is common. A complement plus A, B 1. So this results in C. So that is equal to right hand side. So this one is proved. Another example, prove that a plus b, a complement plus c, b plus c is equals to a plus b, a complement plus c. So here we will see that whether we are able to get this one or whether we need to go with both the left hand side and right hand side. So let's see when we start with the left hand side. Left hand side is a plus b, a complement plus c, b plus c. So firstly we need to expand this because we don't have any other option over here. So a complement, ac, a complement b, and bc. Then we have b mod c. We again need to expand this a complement b. Okay, before that, what we see over here, we have a complement which is actually 0. So we don't need to use this one in expansion. What we are left with, a c plus a complement b plus bc into b plus c. Now expand this. So firstly we have a b c, then a c c, a complement b b, then a complement bc, then lastly this one is expanded bbc plus bcc. Now first term it will remain as it is. Here we have c and c, or operation and operation of any variable with itself results in the same variable, so it's a c. Similarly here it reduces to a complement b, then we have a complement bc, this one will reduce to bc, and then again bc. B and C, they are all together, they will result in B and C only. So we have ABC plus AC plus A complement B, A complement BC plus BC. So this is up to where we have reduced. Now what can we do? We can combine these two terms. From these two terms, B and C, that is common, A plus A complement we have, plus AB plus A complement B plus BC. A plus A complement is always 1. So this it is BC plus AC plus A complement B plus BC. Again we have BC, BC. So they will result in one term only. And that one term is BC. Then we have AC plus A complement B. Now in this, if we see, we don't have any other option. If we take C common from here, then it becomes C into A plus B. Or if we take B common from here, then we have A complement B. So we are not able to reduce it further. So our left hand side is equal to this. Now let's look into the right hand side. Right hand side is A plus B into A complement C. Right hand side is A plus B into A complement plus C. So let's expand this. So this will be equal to A into A complement plus AC plus A complement B plus BC. Now A into A complement is 0. So this was AC plus A complement B plus BC. Now what we see, left hand side and right hand side both are equal now. So this is how we have to solve. Now depending upon what is given in the expression, you always need to look for that which rule is applicable so that we are going for to the minimized expression. In the next video, I will discuss the K maps, that how they are helpful in giving us the minimized expressions. I hope you are able to understand the Boolean algebra over here. You always need to practice as much as possible, only then you will have the you will lead to the minimized expression. If you feel this video is helpful to you, then consider subscribing the channel. Thanks for watching the video.